Hi, hello everyone. Welcome to our channel. My name is Kirtana, studying first BTech in Computer Science Engineering in Sri Vishnu Engineering College for Women in Bhimavaram. Now I came with a problem statement converting decimal number to a binary number. Here the problem statement is writing a C program to enter a decimal number and calculate and display the binary equivalent of that number. Now let us discuss how to convert decimal to binary. For example, I am taking a number 10. We should divide this number only with 2. By dividing this number with 2, we get the quotient as 5 and the remainder as 0. Again dividing with 2, we get the quotient 2 and remainder is 1. By continuing this process, we get the quotients and remainders. By writing these remainders in the reverse order, we get the binary number. Here it gives the binary number. So the binary number for 10 is 1010. Now let us take an example of a fractional number. Here we can do the binary number individually for these two, 10 and 0.25. Previously we have discussed the binary value for 10 is 1010. Now we'll discuss the binary value for 0.25. First of all, multiply this number with 2. We'll get 0.5. Here the value before the decimal is marked and the value of the decimal is multiplied again with 2. Then we got 1. Here we can stop this process. The value before the decimal are the binary values for the 0.25. Here 0, 1 are the binary values for 0.25 and these are placed after the decimal, and the binary values for 101 for 10 is 1010. Here we got the binary value for 10.25. Now let us take another example, 10.3. Let us see binary value for 0.3. Multiply this with 2, then we'll get 0.6. The value after decimal is again multiplied with 2. 0.6 into 2 equal to 1.2. Then the value after the decimal, that is 0.2, is multiplied with 2. Then we'll get 0.4. Again continuing this process. By continuing this process, we will get the values continuously without any stopping. Then we can take the values up to 10 steps. Here you can see the 10 steps. Then we can note down the values before the decimal point. Here it is the binary value for 0.3. Now binary value for 10 is 1010. This is the final value for the binary value of 10.3. Now let's declare the variables decimal, integer part and fractional part. We all know that decimal part has two types, integer part and fractional part. Here we should calculate the binary number for both integer part and fractional part. Here we written the statement printf enter a decimal, scanf %f and decimal. Here we give decimal value as input. Now coming to the statement integer part equal to int of decimal. Integer part has the value of only integer value of the decimal. Next, fractional part is obtained by subtracting integer part from the decimal. Here we are calling the function convert integer to binary. Let's get into the function convert integer to binary. Here is the function convert integer to binary. Here we are declaring a binary array and we are declaring index initialized with 0. Here we check whether integer part is 0 or not. If integer part is 0, then we'll print 0 because the binary value of 0 is also 0. Coming to the while loop, here if we divide integer part with 2, we'll get the remainder, and the remainder is stored in the binary array. And the integer part is divided by 2 and again stored in the integer part. And index is incremented. The while loop is iterated until integer part is greater than 0. Now we got the binary values. Then we should also print the binary values. For printing the binary values, we should print the remainder in reverse order. For that we use while loop, for loop. Here we should initialize I with index -1 and we print the binary value and we decrement the I value and we iterate the for loop until I is greater than 0. Next, coming to the fractional part. Here you can see that if fractional part greater than 0, print dot. Here we are calling the function convert fraction to binary. Now let's get into the function convert fraction to binary. Here is the function convert fraction to binary. Here we declare count and initialized with 0 and we declare bit. Here you can see the while loop. Fractional part is multiplied with 2 and again stored in the fractional part. Next, bit is equal to int of fractional part gives that integer value of fractional part is stored in bit. Then we'll print bit. Again fractional part minus equal to bit indicates that bit subtracted from the fractional part is again stored in the fractional part. Then count is incremented. This while loop is iterated until fractional part is greater than 0 and count less than 0. Here this count indicates that, as we discussed before, if we have more statements, more values, then we should take values up to 10. Now the convert fraction to binary loop function is exited and main function is closed. Now let's see the output of this program. Here I am giving an integer number. For example, I have given 12. Here we got the output. Now let us give a fractional number. Here I am giving a fractional number as 12.3. Here you can see the binary representation. Thank you.
Everyone, this is Latya from CSE-B, studying Sri Vishnu Engineering College for Women, Autonomous, First B.Tech, Department of CSE, SWEC A Block, Bhimavaram. This activity is guided by Dr. M. Prasad, Sir, Assistant Professor. Now let's work out on the program matrix multiplication using pointers. So here is the program. First I have included the header file stdio.h and I have written the main function. In main function first I have declared the two matrices M1 and M2 in two-dimensional arrays, and Rm is the resultant matrix. Here R1, C1, R2, C2 are the rows and columns of M1 and M2 respectively. Isaac are the loop counters. In the second line, I declare the pointers P1 in which they hold the base address of M1, and P2 is the pointer which holds the base address of M2, and P3 holds the base address of resultant matrix. Here I have taken the printf statement to enter the rows and columns in the matrix and scan the values of R1, C1, R2, C2. And then in which we have matrix multiplication, we have this condition that the column of first matrix should be equals to the number of rows of the second matrix. So I have written the condition, if condition C1, if C1 is not equals to R2, then the matrix multiplication is not possible. If the condition fails, that means C1 is equals to R2, then it continues to execute the code. So in this code, this code is for taking elements as input that I highlighted here. This code is for taking elements as input. Let us understand this code more precisely. Now let's understand this code separately. In this first loop I have taken I, which controls the number of rows, and in the second loop I have taken Z, which controls the number of columns, and I have also taken a printf statement, and in scanf I have taken an expression called P1 plus I into C1 plus Z. Let us understand the expression now. First of all, I am assuming that R1 is equals to 2 and C1 is equals to 2 and P1 is equals to 10, which is the base address of the matrix 1. So let us go into the loop and let's have a look. In this, I is initialized to 0, 0 less than 2. It goes to the next loop, Z equals to 0, 0 less than 2. And it executes the printf statement, enter matrix 1, percentage d row and percentage d column, element I plus 1, Z plus 1. And in scanf, we have to substitute the values. 10 plus I is 0 into C is 2 plus Z is 2 into 4. 4 is like we have this arithmetic operations in pointers. We have to multiply with the number of bytes it have each element of the array takes. So by calculating this, we will get 10, and again going to the Z loop, Z is incremented to 1, 1 less than 2. The printf statement is executed. In next scanf, 10 plus I is 0 and C1 is 2 plus Z is incremented to 1, so 1 into 4 bytes is equals to 14. And next it goes to the Z loop, Z plus Z is incremented to 2, 2 less than 2. The condition is failed, so it goes to the first loop again. I is incremented to 1, I less than 2. So Z equals to 0 is again initialized. The printf statement is executed. In scanf, P1 is equals to 10, I is 1, C1 is 2 plus Z is 0 again into 4 bytes is equals to 18, and again goes to the Z loop. Z is incremented to 1, 1 is less than 2. The printf statement is executed, and in scanf, 10 plus 1 into 2 plus 1 into 4 bytes is equals to 22. And again goes to the Z loop. Z is incremented to 2, 2 less than 2. It fails, so it again goes to the I loop. I is incremented to 2, 2 less than 2. So the condition fails, and it comes out of the whole for loop, So now we have read all the elements in the matrix 1. By observing the addresses, we can say that each element occupies 4 bytes, and also the next element is allocated right next to the previous one. So this is called as contiguous allocation. In this way, all the matrix 2 is also allocated. The same process is followed in the matrix 2 too. Let's come back to the program. We have taken the input values, so let's do the matrix multiplication now. So this is the code for the matrix multiplication. Let us understand this code more precisely. So this is the code for the matrix multiplication. Here I have taken again the I loop and Z loop to control rows and columns, and I have taken an expression similar to the previous one for resultant matrix P3. Here I have also taken a K loop to do matrix multiplication. So let's understand this code more practically. Let us assume that P3 is equals to 20, like 20th address. So let us go into the code. I is initialized to 0, 0 less than 2, and Z is 0, 0 less than 2. and P3 is 20, 20 plus 0 into 2 plus 0, that is 28th address is allocated with 0, is initially received with 0, and K is 0, 0 less than 2. In 0, 20, P3 is 20, 20 plus I is 0 into C2 is 2 plus I is 0 is equals to pointer of 10 plus I is 0 into C1 is 2 plus K is 0. Here it is into pointer of P2 is 30 plus I have taken P2 as 30 plus K is 0 into C2 is 2 plus I is 0. By calculating these expression we will get a value, not an address, because I have used a pointer symbol here, which means we will get a value, not an address. So here in 20th address we will allocate the value of multiplication of the value in the 10th address into value of the 30th address. The both multiplication of the both values we will be storing in the 20th address of the resultant matrix. In this way all the values are allocated in the contiguous allocation, like 20, 24, 24, 28. It continues like that in a continuous allocation. Now let's back to our program. Now I've completed the matrix multiplication, so I wanted to print the resultant matrix. For resultant matrix, again I am using the I loop and J loop. In this I am using the same expression that I have used for resultant matrix, so that I can print the result of the resultant elements of the multiplication, and I have also used a slash n for the pattern of matrix. Now let's run the program and see the output. First I am giving some random values like 2, 4, 7, 8. It gave me the output matrix multiplication is not possible because the C1 and R2 are not equal. So it gave me the output matrix multiplication is not possible. Let us try with another case. Now I am taking a square matrix, that is 2, 2, 2 and 2. I am taking some random values. Sorry. And I have got the resultant matrix 17, 16, 65, 64. Now let's try in another case. Now I am taking non-square matrix 2, 3, 3 and 1. Taking some random values. And I've got the resultant matrix 24 and 43. So this is the program on matrix multiplication using pointers. Hope this video helps you. Thank you.